Students, till now we have talked about cuboid, right circular cone and right circular cylinder. Now we are going to discuss about another solid figure, that is a sphere, right? Sphere is nothing but the 3D extension of a circle. Now we all know what is a circle. A circle is the collection of all the points which are equidistant from a fixed point, right? If we apply this definition in a space or in 3 dimensions, then we'll obtain a sphere. The basic examples of sphere would be a football. You must have seen a football or a globe. They are nothing but spheres. So the definition of sphere is all the points that are at a fixed distance from a fixed point. But what is so different about a sphere? That all those points, they are not lying on a same plane, they are distributed in the space. So I'm going to write 3D extension of circle, right? 3-dimensional extension of circle. Now what is the fixed point called in a sphere? As it is called the center in a circle, it will be called the same in a sphere as well. So we call this point O as the center of the sphere, right? And the fixed distance is also called the radius of the sphere, which is denoted by R. So fixed distance is radius denoted by R. So a sphere is collection of all the points which are equidistant from a fixed point, which is called the center, and the fixed distance which is called the radius, right? Now how many surfaces do a sphere have? As we have discussed this for other figures, a sphere, it has only and only one surface. It has only one surface, and that too is a curved surface. The only surface of a sphere is a curved surface. So I'm going to write here, it has only one surface, which is a curved surface, right? It has no flat surface, right? Now we discussed about two terms, that is CSA and TSA. CSA stands for curved surface area and TSA stands for total surface area. Now for different figures, these two terms, they were different. The curved surface area included the walls for a cuboid, and the total surface area included the top and the bottom as well, right? These two figures or these two quantities, they were different for different figures. But as sphere has only one surface, and which is a curved surface, the curved surface area and the total surface area would be same in the case of sphere. And the formula for curved surface area or the total surface area of a sphere is 4 pi r square, where r is nothing but the radius of the sphere, right? R is the radius of the sphere. So the curved surface area or the total surface area of a sphere is 4 pi r square. Now what if I cut the sphere into two halves using a knife, right? So this is my knife marked by red, and I am cutting the sphere from the center into two halves, right? So these are the two halves that I have obtained. They look similar to a coconut shell, right? When we cut coconut into two halves, it looks similar to that only. So these two halves, they are called as hemispheres. These are called hemispheres, right? Now you might be wondering, in mathematics sometimes we use the term hemi and sometimes we use the term semi. What is the difference between hemi and semi, right? Hemi and semi, right? We call a circle, half of a circle as semicircle, but we call half of a sphere as hemisphere, right? Now hemi, it is a Greek word. Hemi is a Greek word, right? So in all the words using Greek language, you will find the usage of hemi. And semi, it is a Latin word. It has Latin origin, right? Both the words, they are almost meaning the same. They mean that half of something. Both means half of something. But the origin of both the words, it is different, right? So sometimes we call it a semicircle and sometimes we call it a hemisphere. But the meaning is same, that is half of something, right? So when I chopped the sphere into two halves, I got a hemisphere, right? Now talking about the surfaces in a hemisphere, there are two surfaces in a hemisphere. The first one is this surface, which is nothing but the circle, right? The circle or the base circle. And the second surface is this curved surface, which was already present in a sphere as well. So we have seen that a hemisphere, it has two surfaces. One is the base circle and another one is the curved surface, right? So when we talk about the curved surface area and the total surface area of a hemisphere, that those two quantities would be different for a hemisphere. Why? Because it has two surfaces, one is curved and another one is flat. So talking about the curved surface area, as we know that for a sphere, the curved surface area is equal to 4 pi r square, right? So if I am dividing the sphere into two parts, the area or the curved surface area of the first part or any of the parts would be half of this curved surface area. So I can write curved surface area would be equal to half of the curved surface area of the sphere, that is 4 pi r square. So half into 4 pi r square is equal to 2 pi r square. This is the curved surface area of a hemisphere, right? Curved surface area of a hemisphere. Now we know the formula for a total surface area. What is the formula for total surface area? It is curved surface area plus the area of the surface that is left or remaining. So I can write total surface area as the curved surface area plus remaining area plus remaining area. Now the curved surface area for a hemisphere, it is equal to 2 pi r square, right? And the area that is remaining is nothing but a circle whose radius is also equal to r. This is a circle whose radius is equal to r. So I can write the area of the base surface or the base circle would be equal to pi r square plus pi r square. This is nothing but the TSA or the total surface area of a hemisphere. So what is 2 pi r square plus pi r square? It is nothing but 3 pi r square. So we have obtained the formulas for curved surface area and total surface area for a hemisphere. The curved surface area is 2 pi r square, right, because it includes the curved surface only, and the total surface area, which includes the curved surface as well as the base circle, is equal to 3 pi r square. Now let us see some questions on a sphere as well as a hemisphere.